Again, we have an array of objects, right? We can create an array of objects, which is circles, an array of circles. When we're doing this, an array of reference, an array of object is actually an array of reference variables, which involve two levels of referencing as shown in this figure. Circle array reference to an array, and circle array with the index reference to the circle class. You can look at this example on your own. And now we look at immutable objects and classes. So what is immutable objects? The contents of an object cannot be changed once the object is created. The object is called an immutable object, and its class is called an immutable class. So how we can make this? That means we're not going to have the setters method inside the circle. So if we remove the setter out, then the object cannot be changed once it's created. So this is called immutable class. And it cannot be changed because we encapsulate. The radius is private. Remember, we do encapsulation, make the data field as private. You cannot set it, so that's how we protect the data. So a class without private data fields and without mutators is not necessarily immutable, right? Our private data fields without mutators. Mutator means the setters methods. It's not necessary that it's going to be immutable. For example, the following class student has all private data fields and no mutators, no setters, right? But it's mutable. Let's look at student class, private int ID, private birth date, and birthday is another class that has year, month, day. They're all private. Constructor, and they happen to have one setter, set year, right? Student, no setters, or we call no mutators. Setter or mutators, right? There's no set ID, no set birthday. Only get ID and get birthday. Now let's test. Public static void main student generate student with ID, date, year, month, and day, birthday. So student.get birthday, return the date. Date dot set year. So if we do set year, it happens to be the date happen to have the setters. So this is showing that this is not an immutable. Even student doesn't have any setters, but it happened that birth date happened to have setters, right? So a class with all private data fields and without mutator is not necessarily immutable. That is a good example. It is mutable, it's not immutable. So what class is immutable? A class to be immutable, it must mark all their fields private and provide no mutator methods and no accessor methods. Mutator are setters. Accessors are getters. That would return a reference to a mutable data field object. Scope of the variables. The scope of instance and static variables is the entire class. They can be declared anywhere inside a class, right? Because it's the data fields of the class. The scope of a local variable starts from its declaration and continues to the end of the block that contains the variable. a local variable must be initialized explicitly before it can be used. So let's look at example. So these are the scope of the instant and static variables. These are instant and static variables. So it's entire class, right? Anywhere inside class, you can use declare like pi, radius. We know that, like this dot radius, like that. Count, we refer to them, the entire class. But if you look at a local variable just like if I have, let's create like int x equals to 7. So that's local to this. If I want to refer to x here, if it has document errors because there's no x inside of that. So it's only scope is limited to the block. That means this curly braces. Like even if I say like if x equals to 7, and in this block I can have another local in y equals to 6. So this y only limit in the scope of this curly braces inside if. Like if I refers to y outside, if you never know what is y. See? So this is what it's mean here. Scope of local variable start from its declaration and continues to end of the block. So start from its declarations until it end of the block. So if I declare it, if I have something else before, like if I try to do refer to y here, of course it will never know because even inside the block, but it declare after it has to valid when it declare to the end of the block. Only highlighted area. Okay? And a local variable must be initialized explicitly before it can be used. That's it. Like if I do not initialize, there's an error. You can't, right? It has to be initialized because it is a local variable. It's not like an instant variable. You don't need to initialize first. That's the difference. And this keyword is the name of a reference that refers to an object itself. So when you look at, I use this, I refer to the object like if I use circle, right? Circle set radius. So this refers to circle itself, which is the class circle, because circle create from circle class. Right? This refers to the circle itself, which is a class. And then I use dot operators to get the properties or data field of the circle back. So that's why I refer to this operators. One common use of this keyword is reference a class hidden data field. That's it. I reference to the hidden data field, which is private. Another common use of this keyword to enable a constructor to invoke another constructor of the same class. Enable a constructor to invoke another constructor of the same class. So let's look at an example. So reference hidden data field this dot I. So dash I equals to I local variables here. Scope only in I inside the block. Suppose that F1 and F2 are two objects of F. So I say F1 is set I 10. It's going to take 10 into parameters and set this dot I to 10, where this reference to F1 and F2 dot set I to 45. This dot I will reference to F2. All right. Now, another use of the constructor is using this to invoke another constructor. Let's look at, I create a circle class, double radius. This is a constructor that this explicitly used to reference the data field radius that is hidden of the object, right? Which is this. Now this is used to invoke this constructor. See that? So instead of I say radius equals to 1 like I used to do in this, I can actually use this to invoke the constructor, which is invoke this constructor. That's another use of this, right? Another constructor, and that works the same. This keyword to enable a constructor to invoke another constructor of the same class, right? Invoke another constructor of the same class. Then you don't have to radius equals to 1 because radius equals to that being set to this. And if you invoke, then you don't need to do count plus plus because this is already do count plus plus. So the whole construct being called. Okay. And you see that if you get error, it's just called radius times. This one uses map.pi. Every instant variable belongs to an instant represented by this, which is normally omitted. Right, so this is an instant variable's radius. You can also use this the radius to refer to the radius of the instant variables of the object that it refers to. But it's normally omitted. You may see we don't use this. We only use when we have the radius like that to make it more readable, like to send in. When there's no parameters radius, then you normally omit in this. And that's the end of Chapter 9, Object and Classes.